Welcome. Today we're going to go over some possible test questions you might encounter in a circuit analysis course. We're going to start off with this. This is actually a short answer question. It asked us, when considering the total resistance between nodes 1 and 2 in each of these diagrams, circle the correct answer. Now, at first glance, you might think, well, I'll just go ahead and calculate the equivalent resistance in each of these circuits. But that's actually going to take you too long. Remember, this is a test. Part of doing well in a test is just knowing how to take a test. In this case, they're not really going to test to see if you can calculate the equivalent resistance. It's just a short answer. It's just testing to see if you have an intuitive feel as to what configuration actually gives you a lesser or greater resistance. So let's look at the circuits quickly. This is going to give you the greatest resistance. Resistors in series will always give you a greater resistance than anything in parallel. Why? Well, because anytime you have something in parallel, you give the opportunity for the current to split along different branches. By doing that, you're basically giving the current more options and a bigger quote-unquote pipe to go through, and thus it's going to encounter less total resistance. So in this case, A would have the most resistance, B would have kind of a middle level of resistance, and C would have the least resistance. It's got the most branches for the current to break up and more paths to follow to complete the circuit. So therefore, A is the greatest, B is in between, and C is the least. And so the correct answer would be A. Circuit A has a larger total resistance than circuit B and C. And that would be the answer for that one. Let's go to a second question. This again is another short answer question. This is a cleverly designed question. At first glance, again, you're tempted, well, I can just do some simple circuit analysis. But it's actually testing a few other things. In this case, we've got to circle true false for each of the choices. Now, if you look at the equations, look at this first one right here. You've got a current times a resistor times a resistor. Current, resistor, resistor. Current, voltage times a voltage. So this is current times resistance squared is power. Current times resistance squared is power. I'm sorry, I meant this is just a current. The current is actually labeled IV1 times a voltage. That's also power. So this first equation is all about power, and the units all agree. Let's look at, in contrast, look at option C. You've got IR1 is a current times IR2 is a current, and equals IV1 is another current. So again, it's at least agreeing. I'm going to stop.